Good morning, everyone, or good afternoon, good evening. Welcome to the AI show. We have a really cool show for you today. We are going to be talking about vector search in Azure Cognitive Search. Super interesting topic, lots of cool things happening there. So excited about that. But first, where is everybody coming from? Who is hanging out with us today? Say hello. We love to see where everybody's from because it's so neat to see the world audience that shows up for the AI show. Good morning from Manila. Hey, Mike, what's up? Thanks for hanging out. Seattle, hey, Jay. Good to see you again. Welcome. Canada. Fantastic. My neighbor to the north. I'm in Minnesota. Seth is on vacation again. So he is hopefully having a lovely time, and I'm sure he is. Brooklyn. We got Brooklyn, New York. Awesome. And yeah, so let's jump in and learn more about vector search. Oh, and then the other thing, make sure you hang out after the video because Liam is here to answer all of your questions. So as you're watching the video, get those questions ready because we will be answering them live after the show or after the video. All right. Hey everyone, you're not going to want to miss this episode of the AI Show where we are going to be learning how you can ignite developer innovation with vector search and Azure OpenAI. Welcome. We are joined by Liam, who is a PM for Azure Cognitive Search with Vector Search. Thank you so much for joining us. Why don't you tell us a little bit about yourself?
Oh, thanks for having me on the show, Cassie. It's really nice to be here, be back. So I am the group product manager for Azure Cognitive Search, and I'm really excited to introduce a new capability and show you some of the cool things we've added to the product.
Great. So there's probably a lot of people that might be watching and being like, what is even vector search? So why don't we start with what it is and how and why people might want to use it?
Absolutely. So, one of the places that I think would be great to start is this blog post that we released, which talks a little bit about what Azure Cognitive Search is. And it walks through the details of it, what we've done, and some of the highlights of that. But I think, one of the things that I'd love to do in this session is just kind of help people understand what exactly is vector search? Like, why should I care? How does this compare to the old traditional way of doing text search and just kind of the types of things that this opens up, Cassie?
Okay, so we know that vector embeddings are numbers and somehow we go from text to numbers. Can you kind of explain how that process works?
Yeah, absolutely. This is a really interesting capability that it really opens up because in the traditional, we'll say the older way of searching, it was all based on words. Like you could put in like a runner, running, and it could handle different variations of that, which was okay. But what vectors have really unlocked is this ability to take objects, and an object could be some text, could be an image, could be a video. I mean, it could be a molecule or a gene, and it describes that in a vector space. And all a vector space is a set of numbers that have a description of that. And you can see on the left side how what we can do is we can use different types of models, such as Azure OpenAI has an amazing one, which I'll show using something called ADA002, which has this amazing ability to take text and make a vector representation of it. And what you can do is once you have those descriptions, what you can do is then when you ask a question, like, hey, I'm looking for the capital of Canada, and I can go through and that vectorized query goes through and it tries to find the most closest match in that vector space. And that is the power of a vector database, is it allows us to take massive numbers of vectors or content and quickly get those answers effectively, which leads to amazing ChatGPT experiences and much more.
Right. So it's really enabling a lot of these next level things that we've been seeing in the AI space. So Now I kind of understand a little bit about what vectors are, how we're able to take many types of data sources, turn them into a vector representation, and then be able to perform different tasks in order to really enrich our applications and user experiences. How does one use this? How do we leverage this? What are good scenarios to use it for?
So I have a couple of, or I have some code that I'd love to show to hopefully start showing you some of the things that we can do with this. And luckily, we have some friends coming to talk about some even more advanced scenarios in subsequent sessions with Derek and Varsha. But I thought it would be useful if we just kind of start with this Jupyter notebook, and I can kind of walk through how that all works and show some of those scenarios. Does that work?
That
Kelsey?
sounds awesome. Let's
Cool. So, and by the way, all this code can be referred to from this GitHub repo at the top here, or going to the blog post that you referred to earlier. But let me just walk through this code. So basically what I'm going to do here is I'm just in this first tab, I'm just setting up all the imports for Python. I'm going to be able to use Azure Cognitive Search, which we're going to store all the vectors and do the querying against it. We're going to be using Azure OpenAI because we're using Azure OpenAI to take the text and actually vectorize that content. So all I'm doing here is I'm just setting up my configuration to connect to Azure Cognitive Search. I'm setting up my Azure OpenAI config, and then I'm just creating some connections that I'll be using to interact with Azure Cognitive Search.
Okay, so here it looks like you've already set up an Azure service. Is the Azure service, I know that we're using the cognitive search service, but we're using the vector search capability. Is there a different service that I need to set up, or how do I do that?
Yeah, great question, Cassie. And you're right. I had previously created this Azure Cognitive Search service. You simply just go to the Azure portal and just create the service. And you do not need to do anything special to have vector search. It's just in a new field, a new data type within your search index that stores these numbers, and it allows us to do that similarity, the search, really, really effectively.
Awesome. Thank you.
Cool. So let me keep on going here. And I want to walk through a couple of other pieces of code here. So I have two functions. One is called generated embeddings. And embeddings, vectors, you can think of them as the same thing. All this does is it receives some text and it converts it to an embedding using the Azure OpenAI model called text embeddings A002. And it returns that back. This other function that does something called cosine similarity. And all that is a way of us taking one vector and actually comparing it to another vector and seeing how close they are in similarity. And so this will hopefully give us an idea of how vectors work and why this idea of being able to search is so useful.
So I see here in the engine, you said you're using an OpenAI model.
Mhm.
What models are supported? Can I bring my own, or how do I choose which model to use when I'm doing my vector embeddings?
Yeah, it's really up to you. You can use any model you like. We do find that the vast majority of our customers have been using this A002 model because it's so effective. It's so good over text. However, if you were thinking back to what we were just showing in that architectural diagram, you can do more than text. Like for example, you can do image search. And in a subsequent session, Varsh is going to come in and show how the Florence model from Vision can be used to convert images to embeddings. But you can also use open source models. Some people create their own custom models that are unique to their industry that they can use. So we can support them all.
That's awesome. And that's what I was wondering, because sometimes you have really specific things to the tasks that you're trying to solve. And although these ones are generally the best, right?
That's right.
For all tasks, sometimes you need something more specialized. So all of that is supported. And when you create the engine, or when you're using the API here, you can choose the best model.
That's exactly right. That's
Great.
exactly right. Cool. So let's keep going. And I want to show you an actual example. So Cassie, I love food. So I thought that, a good set of data to use would be, recipes or just different food examples to show this. So I have two of my favorite foods. I have enchilada, and describes what that is, and then pizza. And I have So what I'm going to do is I'm going to generate embeddings for both of these. And let's actually look at what that embedding looks like. So if we look at the first vector and just look at the first 10 digits, this is what ADA002 described that first sentence as, that first set of text as. Now, this means nothing to me, but being able to take those numbers and actually compare them is actually very useful. So let me now do something different. And I'm going to say, okay, what is a good Mexican food? And you can see here, this is my query. I'm going to convert it to a vector, and then I'm going to say, using that cosine similarity, convert the first vector to the question, the second one, and let's see which one is more similar. And if we look at this, we can see here that the first one, which refers to enchiladas, is actually more relevant. And this is why ADA, the 002 model, is so great. Like it doesn't, there's nothing referring to Mexico or Mexican in that first sentence, but it knew that the similarity between Mexican and enchilada was much more similar. Or if I change this to Italian, and actually let's misspell it here, right? We can actually see here that the numbers change slightly. So it handles these semantics so much more effectively than some of the ways that we were doing in the textual search.
I think that was a really great way to break down how it's able to understand, right? We get words that are turned into numbers, and then it's really easy to see what's similar, right? Because in the embedded space, they're closer together, therefore they're similar.
Exactly. And so hopefully I've shown this is doing this all in Python. This is just using out of the box code. But realistically, most people don't just have two sentences. They have massive numbers of documents that they need to search over. And so having to scan through every single one of these pieces of text and try to find the most similar is not an efficient way of doing this. And that's where vector databases like Azure Cognitive Search really allow us to scale that. So you can put in massive amounts of vectors and search through them really quickly and efficiently. And I'd love to show how that works within Cognitive Search, Cassie.
That'd be awesome. I can my brain's going with all the different ways that would be useful in so many different fields. I used to work in the legal field, so tons of documents there. And this is really cool.
Yeah,
I don't think we need to think, or it's not hard to think about what scenarios people might want to use this for. I think that people are probably going crazy with ideas right now.
It's so true. And legal is such an interesting one as well, because all the different ways that a single thing is referred to, like all the different variations of those words, is really hard. And finding the right content can be hard if you don't know those semantics or those semantically similar words. And this really helps in that space. So let's go into a little bit more of an extensive example. And so here I just have 4 different examples of content that I want to load into Cognitive Search, that I want to do vector search over. So we have the first ones, which talked about the enchilada and the pizza. There's another one here that has a little bit more about a secret ingredients for pizza sauce. And this is just another random sentence. You'll notice here that we've added categories to this as well, because sometimes filtering is important as well. So let me just take that JSON, and all I'm going to do is for every single item in that array, I'm just going to create an embedding for it, or a vector for it. So it's going to run through. It's just going to go through each one, and it's going to add that. And if I look at this first one here, you'll see that it looks, pretty much similar, right? Like it's got the same text. Sorry, there's a lot of numbers here to scroll up, but we can actually see here that we have the first item, the enchilada, and here's that vector representation of it. So that's there. Now, what I'm going to do is I'm going to load this into Azure Cognitive Search. And I want to show you how this works. In Azure Cognitive Search, we have something called a search index. A index is just almost like a table in a database where you have different fields or columns that you can store the data, and those fields have different capabilities. Like, for example, I have a unique identifier for my recipe. Remember, I was talking about the category, which I can then filter or group if I want to. I have the actual text of the recipe. And here's that new data type we're referring to, which is a vector field that allows me to store those numbers and use it for semantic search. So I'm going to create that index. We have some configuration for the vector work that we can do. So like this helps us from the performance and accuracy trade-offs that you can apply when you're doing that search. And then I'm not gonna talk about this right now, but I'm gonna show you in a few minutes this other capability we have called semantic. So I'm gonna leave that for now, and then we're gonna just create that index. Now that I've created the index, I'm gonna take my documents, load them up, which includes all that vector information. It's now existing in Azure Cognitive Search, and I can actually start doing my searches against it. So the first one that I'm going to do is I'm going to search for Italian food. And of course, I misspelled it here just to make sure it's working. It's going to go through, execute that search. You can see how it's converting that query to an embedding, and it's going to use my recipe vector field because you can have multiple vector fields in Azure Cognitive Search. And let's print out the results. So we see here that it did pretty well. Like we put in Italian food, and we have all kinds of different results that came back here. We have this one about pizza. We have this one about the pizza sauce and some other items that aren't quite as relevant, but it came up. So as you can see here, we got this result that came back, but sometimes it's important to be able to adjust the categories based on what's important to you. Like maybe if I'm going to a jewelry store, I might want to filter it based on whether it's a necklace or a bracelet. Or in this case, I have categories of standard content and premium content. And maybe I might want to say is, okay, I found a great match for here, but I only want to bring back content that was standard. So what I can do is, because Cognitive Search has a lot more functionality than just the vectors, I can make a change to this and just say, let me filter where the category equals standard. Execute that exact same search, and you can see here how it only brought back that specific information. So being able to allow us to enable metadata and filtering from that is pretty critical as well.
Yeah, that's super helpful. So I might have a category of documents that I want to already section out, and then do my vector search on top of that to get really exact results.
Exactly. And so one of the things, Cassie, I'd love to do is talk a little bit more about some of the limitations of vector search and some of the things that we've approached to help enable vector search along with other different techniques. And I think a good way to do that is if I take a different example here. I'm going to change the query from Italian food to just food with cheese. You'll notice in this result, which was just using vectors, it wasn't using text or anything like that, you notice I got an interesting result. You know, I said food with cheese, and you could probably guess that my intent was like a recipe or food that includes cheese. But you'll notice here why it came back. Like cheesy, extremely semantically similar to the word cheese. Food and cook, very similar. And actually the amount of text that was there was pretty similar. So you could understand from a recall perspective that vectors are really good at why it came back and why it was pretty effective. But realistically, that's not my intent. I was probably wanting something more like an enchilada or pizza. And that's why what we have is we've also added not only vector search support, but we've added additional capabilities. And we have two things that really help there. The first is something called hybrid. And I want to be very clear on how we define hybrid, because there's a couple of different definitions. But what we mean by hybrid is that it leverages scores from vectors as well as scores from text, the traditional text, and using both. Text is really good at recall. So if we use both, that combines and allows us to bump the relevancy generally, and this is what the industry generally says, a lot better. But on top of that, we have another ranking layer called semantic search, which is a set of models, family models that come from Bing that add an extra layer of ranking. So I'd love to show you what that looks like when I apply this.
Yeah. So these are just things you're going to add in. So with this to your search query to add
Exactly.
in those additional. That's it. Okay. Cool.
Yeah. And so when you're asking about creating the vector search,
Hmm.
that is one thing you do need to enable in your search service. You just turn it on. We have a free option and a paid option if you wish. But you can see here, I'm just telling it I'm going to use a semantic query. I'm using it in English. If you recall when I was creating the index, I had a configuration for that. So I'm going to use it. And now I'm also going to pass in the query. So not only am I passing in the vector, but I'm actually passing the text of food with cheese. And if we search this now, you'll notice that the results that come back are a bit more effective, right? Like it did bring the cheesy one, but it's much lower down in the list because all of these things of using text for hybrid, as well as our updated semantic model, which by the way, we just deployed a brand new updated model at the start of August, which has been really, really effective. And this has really made a big improvement to the relevancy of results.
Yeah, that's awesome. That's so cool to be able to see that adding those into your search queries can improve the results that much.
Cool. Yeah, this is so important, especially
Hmm.
um, earlier. Seth and I were talking about enterprise ChatGPT and leveraging Azure Cognitive Search to recall information that can help the chat experience. And this right here is so important because you can only send a certain amount of content into Azure OpenAI because of token limits and costs. So it is critical to get the top results as as effectively as you can. So this is really important, not only to search, but even to some of these generative AI applications.
Yeah, that's so true. Like when I have been playing with prompt flow and Azure ML and generating those prompts,
Yeah,
using cognitive search with vector embeddings has been extremely helpful in being able to get the correct documentation to give context to the large language model to get those answers. So this adding your own data into large language models is a game changer in application development.
yeah, absolutely. And one of the things that I'd love to leave everyone with for some of the subsequent sessions that we're going to go through is that I've shown a really simple example, a very small set of data, but we actually used Azure OpenAI to create a couple of thousand recipes as well as images for those recipes. And so if I change to that index, and I'm just going to do a quick search to give you an idea of what we're going to do. I'm going to try to find an Italian recipe that includes meat and Parmesan, which I completely misspelled so much in here. And you can see here the result that comes back. We have the image. We're going to show some cool things around image search, as well as the ability to understand different variations of meat, misspelling, all these things. So I'm sure hopeful that everyone's going to join for some of those subsequent sessions as well.
Yeah, that is super cool. So the only thing that I changed here, can you go back up to the query that you sent in?
Absolutely.
The only thing you changed was the index you were pointing at. The query and everything else you sent in is the same.
That is correct. That was the
Wow.
only change they made. It has the exact same type of queries. It is using semantic, as you can see here. I do have a couple additional fields in this one that I didn't have in the under index. So that's
Mhm.
basically the only change.
Amazing
Cool.
and delicious. I mean, now I want Italian food.
Yeah, I know. That's the downside of doing this one. It sure makes me very hungry every time I walk through
Indeed.
it. But yeah, hopefully that gives everyone a good idea of what vector search is, and hopefully it inspires some ideas of things that you can do.
I mean, the possibilities are endless. I think that probably a lot of people have had to like the problems that we're solving are problems that developers have had before, but we haven't had these tools to do it this well.
Yeah,
So I think that there's probably even different scenarios where people have tried to solve this and probably not get nearly the results that you can now do by adding in vector search and these different embeddings into what you already have.
absolutely. It really, really has changed the game. That's for sure.
Okay, so we went over a lot of really cool information on how to start using vector search within Azure Cognitive Search. Where can people go to learn more and get started?
Yeah. So I think the best place is what we can refer to that back to this blog post that we're talking about. But we also have the Azure Cognitive Search documentation, which is always a great resource to learn more and get started as well.
Awesome. So go check out these resources, get started. And thank you so much for hanging out with us today.
Thank you.
All right. So there was so much goodness there. I am going to invite Liam, who is here live with us. Welcome.
Hey, Cassie.
Thank you so much for, again, coming to answer people's questions. I have a couple already as we wait, and then we'll go into everyone else's
Sounds great.
that I'm seeing here too. And everyone, if you have more, please put them in the chat as we'll be looking for those and answering them. So you showed in that example, you had just kind of set up some JSON data to set up an index. But in general, people are going to have tons of data that they're going to want to be able to do. What tooling or what's the process like for them to ingest and index all of their data?
Yeah, that's one area that we didn't get into. So what I was doing was we have two ways of getting data into Azure Cognitive Search. There is a push model, which is what we were using, where you just create some JSON, just programmatically send it to it, and it indexes it. The other thing that we have in Azure Cognitive Search is something called the indexer, which you can think of as like a crawler. It can connect to Azure data sources, and it's a no code option that allows you to connect to those sources. So if you have PDFs in Azure Blob or data and sits in your SQL databases that you want to ingest and do this against, it's a very convenient way to do that. And then the great part is that you don't have to do all this coding. You just connect to it. It will do change tracking, and you can even do the vectorization. And even when a document changes, it just updates it and sends it in. So it's a very convenient way of doing that.
And what are the different types of data stores I can point to? So like, is it just blob storage? What are the different data sources that are supported?
We pretty much support all of the Azure data sources.
Okay.
ADLS Gen 2, Cosmos Database, Azure SQL, like we could go on and on. But there's also other options. For example, Azure Data Factory, Fabric also has a lot of connectors, which also support Azure Cognitive Search. So that's, if you happen to be using that technology, it's also a great way of tying it in.
Okay, cool. So it sounds like it'll be pretty easy for people to get their data in. There's lots of tooling
Absolutely.
And things to get that set up and index so that they can leverage these abilities.
Yeah, that's definitely one of the things that we try to do is, as a pass, try to make things, as simple and as straightforward as possible so that we can have smart defaults tying in the data as effectively as possible.
Great. And then one thing you had talked about was the ability to add in additional functionality first, like semantics and things like that with the Bing models. But sometimes you want more of a like static traditional search on top of that. How does it blend those two functionalities of doing, the more fuzzy searches and the semantics, and then also sometimes being able to find very static text strings together?
Yeah, that's a really interesting question. And in fact, maybe I'll go back to that legal example that you had brought up earlier, Cassie, because, for example, one of the things that we see in the legal space is often, you don't want extreme fuzziness. Like, for example, sometimes you want to search, okay, these are the very precise words I want, or these words need to be in close proximity within 1 or 2 words of each other. And that's not something that vectors are well suited for. They're meant to find semantics and semantically similar terms. But the great part about using the traditional textual search is you can still do all those things. You can put in double quotes around the words, or you can add proximity and say, here are the words, but make sure that they're all within specific distances. There's language analyzers. So if you want to handle phonetics, my last name is a crazy one because whenever I go into a hotel, it's like sometimes it's spelled with a K instead of a C and a U, and just like these things are really hard. And the text search really comes handy for those things.
Awesome. So it sounds like it can support the more traditional stuff while still being able to give you the power of the vector search and semantic abilities that come with cognitive search.
Absolutely.
Okay. C# example. So you were showing the Python API. What languages do we have supported for it?
Yeah. So realistically, you can support anything because we have a REST API, so you can really technically use anything. However, we have SDKs The Python one was the one that I was using. I think you might have a link to a GitHub repo that actually has .NET as well as a JavaScript version as well, just as well as the Python one. Yes, there we go. So that is where you can go to see examples in that particular language. But of course, because of the rest, it really opens it up to whatever you might want to use.
Awesome. So they have the flexibility to use their favorite language. Okay, let's see what other questions we have here. I think that was the main one that I see about semantic search, or not semantic, sorry, vector search. So everyone put your questions in there. Let me see if I had any others that I was thinking of. We talked about how we can get our own data in. We talked about the hybrid capabilities, so supporting the different types of scenarios that people want to be able to do. It's very flexible. Yeah, I don't think I have any other questions. Does anyone else have anything they want to put in the chat? Is there anything else that you think is interesting or you want to share about the service?
So I think we've gone through quite a bit. I just want to give a quick shout out to Derek and Varsha, who are going to be coming on your show subsequently. I've set up like the initial, I've shown very basic things, but they're going to be showing some really cool things of how we can tie in Azure OpenAI, specifically some of the functions, capabilities.
Oh, you're cutting out.
Sorry about that. All right, can you hear me?
However, oh, you cut out there. You're back now.
Sorry about that. I just wanted to mention Derek and Varsha, who are going to be showing some really cool things from Azure OpenAI functions, as well as some of the image search. So I hope they'll come join us for that. So maybe we lost Cassie. So thanks everyone, and hopefully we'll see you in the next.
My capabilities.
Oh, there we go. Hey Cassie, you're back.
Oh, hang on here. Let's see. Now I think you're still frozen, Liam. But thank you so much for coming on the show and answering questions. Like I said, next week, we're going to have a double header. We're going to go even more detail about the different ways. This was like the intro of some of the abilities and things that we have within Azure Cognitive Search, but we are going to learn even more next week. We're going to talk about OpenAI stuff. We're talking about function calling in OpenAI. We're going to talk about, like I said, images and different data sources within vector search. And we're going to go even deeper into all of these really cool capabilities that are coming out. So be sure to tune in next week. That was actually another question I saw. Oh, someone said that I was freezing and that Liam was okay. Interesting. Okay, so I saw the opposite. Sorry about that. But there was another question in here I wanted to show. Someone was asking about how to get notified about future sessions. And the AI show is every Monday at 8:30 Pacific, 10:30 Central. And so you can set a reminder on your calendar. We will be here every Monday morning. And come hang out with us. We're always talking about different things, really cool stuff. And then usually we even will hack on some different projects after. I don't really have much to work or anything to show after today, so we don't have that today, but a lot of times we'll have something cool that we've been working on that we want to share and show. So hopefully if I was cutting out or Liam was cutting out, hopefully you heard what next week's show is about, where it's going to be deeper on the vector search capabilities. We're going to be looking at OpenAI function calling, and then we're also going to be looking at the image capabilities within it. So definitely mark your calendar, put a reminder, and come hang out with us next week. So thanks and have a great rest of your day. See you next time.